So, hello and welcome to another edition of the questions and answers. And today we are going to go through some questions and answers to numerical analysis. And in this video, we are going to focus on two main things. So, how to find the eigenvalue of a given matrix when you have the corresponding eigenvector given to you. In the second part of the video is going to focus on how to use a Rayleigh quotient to find the eigenvalue when you have corresponding eigenvectors after applying the power method. So let's start. You know that after going through these two videos, you should be able to solve any question which involves the use of these two concepts. So the first question here says that given that our vector S is 3, 1 is an eigenvector of this matrix A. So the question says you have to find the eigenvalue that corresponds to the given eigenvector x. So we have this particular eigenvector and we have this matrix A. So we are supposed to find for the eigenvalue corresponding to this. I know this is very simple and most of us can do it, but let's try to revise it. So note that our matrix times the eigenvector x is equal to our eigenvalue times the eigenvector x. So this is our matrix A, this is our eigenvector. So when you decide to make substitution, we are going to get this as we can see here. Right? So when we do this matrix vector multiplication, we are going to end up with this here, which can be simplified further to give us -6, -2. This vector equals lambda 3, 1. But we have 3, 1 here. So we want to find ways to make here also 3, 1. And the only way we can do that is to bring -2 out. So when we bring -2 out, we are going to get -2 multiplying 3, 1 will be equal to lambda 3, 1. So you could see that now this is equal to this. Alright, so that means whatever is here will also be equal to whatever is here. So that means the eigenvalue corresponding to the eigenvector is -2. I hope you get it. So as I said, this one is very, very simple. So you can try that with other questions and you realize it's very simple. So now let's go to the Rayleigh quotient. That's very important. So when we go to the Rayleigh quotient, the formula is given us when you have a corresponding eigenvector x and you have a matrix A, then the eigenvalue lambda is given by this particular formula here. So A times x dot x over x dot x, right? So the dot there stands for the dot product or the inner product. So you're going to illustrate this concept with an example here. So the question reads that use Rayleigh quotient to approximate the eigenvalue of the matrix with eigenvector x, where this is our E and this is our x. So with those of you who can't see well, we are going to write it here for you. So this is our matrix A and this is our eigenvector x, right? So remember that we said that the formula is given as lambda equals A times x dot x over x dot x. So that means you have to find x dot x, the dot product of our x. So finding x dot x is going to give us, no, this is x, so x dot x will give us 1 times 1 plus whatever is here times this plus whatever is here times this, and this is going to give us 1.99999, right? The next thing is to find the product of matrix A and vector x. So finding for the product of the matrix and the vector here is going to give us these vectors we can see here. And remember the formula is still lambda equals ex dot x over x dot x. So that means we have to find ex dot x. Right now we have x dot x, we have ex. So it's left with ex dot x. So this is ex, so and this is x. So when you find dot product of these two, it will give us this times this plus this time this plus this time this, which gives us whatever we can see here. So now our formula is giving us lambda equals ax dot x over x dot x, where these are ax dot x, so that's what you can see here, and these are x dot x, that's what you can see here. So when you do this division, you are going to get negative 0.4142, and it runs through. So when you try to run this to three decimal places, you get negative 0.414, and this happens to be the option B of the question. So that means this is the answer for this particular question. And the first question that we solved, the answer was negative 2, so meaning this. So with this thing that we've done, is very very important for you to take them serious, because they are going to help you to solve lots of questions in your numerical analysis exams. Okay, thank you very much.